Okay, now it's already 8 o'clock. Okay, so I will start now. Okay, so first of all, welcome all of you. So this is, as I promised, I will start the live class one. It begin uh, today and tomorrow night also have. So for today, I will proceed. I will start with the Stpm Biology Semester 1, Chapter 1, Biological Molecule. First topic, I will cover two topics only, water and carbohydrate. So without wasting our time, we continue lah. So, okay. So, I think most of you already learned chapter 1, even already achieved chapter 2, chapter 3. But I need to say that if you have listened my answering technique, actually this chapter is very easy chapter. But unfortunately, although it is easy, but everyone just miss out this chapter and cannot score in this chapter because of it is too easy and no one to focus nobody want to focus it. So actually, for me, I don't care it is easy or not. I think that I assume that all of you are don't know about this, so I will explain in very detail lah. So hopefully my explanation is very clear for you. If you have any question you want to ask, you just type on the chat box only. Okay. Okay, so first of all, water. So actually, water. What is water? We know that in chemistry, the water chemical formula is H2O, right? So if ask me what is water, so in scientific manner, we draw the water molecular structure like this. So if you see that it is a bent tetrahedral shaped structure. So actually, if you want to know what is bent tetrahedral shape structure, actually you already learned in chemistry, right? Chemistry chapter 3. Right. There are base the structure, I think with SPER theory, right? The model that determine the shape of the structure. So for water, it is known as bent tetrahedral shape structure. Why? Because it has two bond pair electrons and two lone pair electrons. So if you see this, oxygen actually contribute two lone pair electrons. So actually got two lone pair electrons at there. And two bond pair because of oxygen atom is bonded with hydrogen atom. And also water is polar molecule. Why it is polar molecule? Because it is unequal distribution of electrical charge. So between the oxygen and hydrogen atom, the charge distribution is different. Is total different. So this is why we call unequal distribution. Actually, you already know in polar molecule, why we call polar molecule? Because of unequal distribution of electrical charge. So we can consider this water as polar molecule. Okay, and also oxygen atom, you will see that oxygen atom actually is the slightly negatively charged atom, right? Because actually if you write oxygen atom alone in chemistry, you write all power of 2 minus, right? And for hydrogen atom, if you write chemistry normally, if hydrogen ion, you write h power of plus, right? So hydrogen atom is slightly positively charged atom. So this is just a general structure of the water molecule. Although it is very easy, but I hope that everyone can memorize lah. It is very simple only. And the degree of the water molecule is 104.5 degree. Okay, so this is just general structure of water molecule structure. Next, this is the spatial characteristic for water molecule. So actually, if you learn in chemistry, there are one part called hydrogen bonding, right? So actually, if you know hydrogen bonding, normally it will relate to water molecule. Although in chemistry, I think got another atom, right? I think it's fluorine and nitrogen atom. Nitrogen atom also can form hydrogen bonding, but in biology, in this chapter, we only learn water only. So water, okay. So water can form hydrogen bonding. This is the special characteristic for water. So what is hydrogen bond? So this is the definition. So hydrogen bonding is where positively charged hydrogen atom attracted to the negatively charged oxygen atom nearby water molecule by force is called hydrogen bond. Meaning that when another got one water molecule is extracted with another water molecule, so normally is hydrogen and oxygen lah. So it is opposite, totally two different water molecule. It is not the same molecule. You don't have to misunderstanding between this bonding and the hydrogen bonding, because hydrogen bonding is the bond between the water molecule one. So it is slightly negatively charged oxygen atom extracted with slightly hydrogen, another water molecule of hydrogen atom to form hydrogen bond. Okay, so this one is the definition of hydrogen bonding lah. So actually, if you seen that one water molecule can form 4 hydrogen bonding to each other. So how it can form 4 hydrogen bond? So first, hydrogen, as I already say, positively charged hydrogen atom can extracted with oxygen atom, negatively charged oxygen atom. So one water molecule have 2 hydrogen atom, right? So 2 hydrogen atoms. So each hydrogen atom will be formed one hydrogen bonding with another water of oxygen molecule. So if you see this diagram, this hydrogen atom is form hydrogen bonding with another water molecule. This hydrogen atom also form hydrogen bonding with another water molecule. So what about others 2 hydrogen bond? So another 2 hydrogen bond is based on oxygen. So oxygen, because of the oxygen has 2 lone pair electron, right? If you see that oxygen have 2 lone pair electron, so it can form 2 hydrogen bond with another 2 water molecule. So that is why say that one water molecule can form 4 hydrogen bond to each other. Okay. Okay, next, this is the most important part lah when you learn about water. So there are 6 main properties of water that you have to know. You must know properties of water. So why we want to learn water? Because of these 6 properties makes water is very important in our life, in our all living things. So firstly, water is act as a universal solvent. Okay, what is solvent? What is the meaning of solvent? So solvent actually is like the liquid or the not solution, is the liquid that can dissolve solute. So I take example lah, Milo. So if you know that solute, solvent, and solution, these 3 terms, solvent is water, no? And solute is what? Solute is Milo powder. Solution is our Milo lah. Milo. When you go out, you drink Milo, right? Milo is our solution, and Milo powder is our solute, and solvent is our water. So water can act as a universal solvent. So these are the 2 explanations. So normally they will use salt, because normally our table salt can be dissolved in water. In the water. So actually, if you know that water is polar molecule, so normally the polar molecule substance will be dissolved in water. But the non-polar molecule like lipid cannot dissolve in water. Like oil, lipid, all of these oil and lipid and fats cannot dissolve in water, right? Why? Because they are non-polar molecule. Okay. So if you see this diagram, okay, when table salt is dissolved in water, so table salt is solid. normally is solid, right? Table salt is solid. When it dissolves in water, so when the solid form of the like salt, example salt is NaCl. So if solid form normally it is packed together, right? The atom is packed together. But when it dissolves in water, the water molecule will extract the not water molecule, the ion, the atom, the ion in within the salt will be extracted by water molecule. So normally if you see that the sodium ion will be extracted by by the oxygen atom. You can see. Sodium ion is attracted by oxygen atom, while chloride ion is attracted by hydrogen atom. So all of these atoms will be extracted by water molecule, and then it will become the structure of the solid. It will become arranged loosely lah. So that is why the salt can be dissolved in water. And another one is water soluble protein. So the example is human lysozyme that found in the lysosome, right? Lysosome. So if you see that the lysozyme also can soluble in water by extract the water molecule. So this is why we call as water act as universal solvent lah. So these are the two examples lah. So this is just a mechanism to show that how water can be extracted by others molecule that is able to be soluble. Next property is about water has low viscosity. So you have to know what is meant by viscosity. So viscosity actually, if you refer to the definition, it is the resistant measure of resistance in liquid. So high viscosity meaning that the flow of the liquid is very slow, like oil. If you know oil, if you pour the oil, the flow is very slow, right? So oil has high viscosity, but water has low viscosity. Meaning when you pour water, it is very fast one. When you pour water, it will directly come out from the cup lah. But compared to oil, when you pour it, the oil will the movement of oil is very slow compared to water. So this is the also very important characteristic of water. Okay. So why water has low viscosity? So because of hydrogen bond. Because hydrogen bond between the water molecule is easy to break down compared to other types of bond. Because you know that water molecule normally in liquid is extracted is bonded between to each other by hydrogen bond, and hydrogen bond actually is not very strong. Not if you compare to covalent bond if you compare to covalent bond, actually hydrogen bond is not strong compared to hydrogen bond. Not compared to covalent bond. And also compared to ionic bond, ionic bond is the strongest bond, right? Strongest bond. But if you compare to covalent bond, it is not very strong, so it is very easily to break down. And another one is water can slide easily to each other, meaning water can move. It easy to move. It can easy not meaning that when water form hydrogen bond to that water molecule, then the water molecule cannot already cannot move. It can move. It can move easily. Not meaning that when it fixed at that part and then water cannot move already. So it can move easily. And another important is why low viscosity important is it can be act as the medium of transportation in living organism. So as in human, when we learn about transport, right? Our blood component normally 90%, about 90%, 70% is plasma, right? And plasma for 90% of plasma is water, right? Is water. Why we need water? Because it can transport. It require transport. And even in plant also, we also need plant also need water, right? Need water for transportation, to transport the hormone, nutrient, mineral ion, all of these to all part of our body and also for plant. And also it can be act as good lubricant to reduce friction within body. So these are the low viscosity explanation. Okay, next characteristic is water has the high specific heat capacity compared to others molecule. Water actually is high already. So if you know that water have the heat capacity of 4.2 joule per gram per degree Celsius. So this is the specific heat capacity of water lah. So if you still remember what is meant by specific heat capacity, so specific heat capacity, if I'm not mistaken, it is the amount of the heat required to increase 1 gram of water, to increase 1 degree Celsius of water in 1 gram of water. Meaning that 4.2 joule meaning is the energy required to increase 1 degree Celsius in 1 gram of water. So 1.2 joule is very high already. So it requires large amount of heat to cause the water increase in temperature. So when you boil your water, actually you boil if you have cook you boil water and boil oil. Which one is more easy to boil? Cook oil, right? Normally it's oil. And also alcohol. Can you boil if you boil alcohol will be burnt, right? So meaning that oil and alcohol actually has low heat specific capacity, but water has high. When you boil water, normally it takes about, if you open very big fire, normally it takes about 5 minutes, right, to boil. To boil. So actually it's already require large amount of heat lah. So when water has high heat capacity, what are the importance? What are the importance to our living organism? So meaning that water temperature in our cells can be maintained constant. Meaning that in our cells, because our cells also made up of water, right? Also contain water. So our cells temperature will not be able to change frequently. Meaning not say that in very hot condition, your cells will also be very hot. Like at the 40 degrees Celsius, when the surrounding temperature is 40 degrees Celsius, but our cell will also maintain about 37 in 37 temperature, 36, 37 degrees Celsius, like that lah. It will not change dramatically. Dramatically. Okay, another one is allow ocean to maintain temperature. So if let's say water does not have high heat specific capacity, meaning our seawater, when you see compared to seawater, when the sun provide the heat to the seawater, and then if no high heat capacity, meaning that the water is easily to boil already. The temperature of water is very increased dramatically. What does this mean? Ocean, the fish, all of the fish, all of the living organism in the ocean cannot survive already, because the temperature is very high, that cannot suitable for the organism to survive. And also it will affect all of the ecosystem. If like that, normally the earth is not suitable for living organism already. Yeah. Why? Because the temperature is changed based on the surrounding temperature. When high, it also become high. When low, it also become low. There are no constant temperature maintained. And also enable enzyme. So because of the high heat specific capacity, it also can enable the enzyme to function optimally. Okay, next, when we talk about specific heat capacity, we also will talk about latent heat vaporization. This is the meaning that the water molecule from liquid, how much of energy require from water to become vapor, from liquid to become vapor. So normally it requires 580 calorie per gram at room temperature. This at room temperature. So 80 calorie. And so also large amount of heat is absorbed to break down the hydrogen bond between water molecule before they can move faster and vaporize. So we want to vaporize the water molecule. Usually is also very difficult because of this property. So this one, it will provide cooling effect for you. So if you see this, in evaporative cooling in hot weather, so if you see that the elephant will spread water from its trunk onto its head, right? Evaporation of this water cool the elephant down. So this one is also same as our human. When we in hot weather, we will sweat, right? Sweating akan berpeluh, right? Kenapa berpeluh? Berpeluh because we need to have a cooling effect. When we sweating, kami berpeluh, the water molecule at our surface body will maintain the temperature of the skin. So it provide the cooling effect to our skin for human, for our skin, but also for elephant. So because of water can maintain the it is not easily to be vaporized, so the water molecule will maintain at in our skin, right? When our sweating, actually water is not easily vaporized, right? So water will maintain in our skin, and then so that the water can provide the cooling effect to us. Okay. Okay, next property is about this one. Water has high surface tension. Okay, this one actually you have to know what is meaning by surface tension. So surface tension, actually you can imagine that the water is very hard on the surface. Meaning by surface tension is the meaning that when you I don't know you guys got that experience or not. When you have a pool of water, when you touch the surface of water, you will feel like the water surface is very hard. If you compare to other liquid, you will feel that the water surface is very hard. And when you straight away pukul itu water surface, awak akan rasa sakit. You can try it later. Maybe you can try it later. Kalau awak pukul kuat-kuat dengan air tu, awak akan rasa sakit. Because kenapa? Because of this surface tension. Why got this surface tension? Because of the cohesion force. Because the hydrogen bond of water molecule of the surface, it will bound strongly to each other. When it only occur on the surface only. Within the depth of the water, normally the hydrogen bond is not bound very strong but at the surface of the water, the hydrogen bond is bound very strong to each other one. So that is why it will provide high surface tension. So that is why if you see some insects, this is not insect like spider, but also some insect like ants, if you see video, you will see that there are some huge population of ants can walk on the water one. Like this spider also, it can walk on the water. Because they will think that the water surface, because of high surface tension, it will provide very hard surface to them, and they can walk as usual, like at the floor like human one. So the high surface tension of water resulting from the collective strength of each hydrogen bond, but because of hydrogen bond also. So it causes the spider can walk on the surface of the bond. So it produces a strong layer of the surface, big and hard to break the water surface one. This is the meaning of surface tension, high surface tension. And on the surface, water has the greater attraction for each other than molecule in the air. So compared in the air, at the surface, the water molecule is attracted very tight compared to the air, and also very inside the water molecule. Okay. Okay. Because of this high surface tension, so you would see that water can be transported in plant by using cohesion adhesion theory. So this theory actually you will learn in detail in chapter semester 2. Semester 2. So actually you don't need to for now lah, you don't need to learn what is cohesion adhesion theory, but actually I think you already learned SPM lah. SPM, you have to know that because of water has high surface tension, it will contribute cohesion adhesion theory. So normally cohesion theory is due to the hydrogen bonding between water molecule that hold together, and adhesion theory is because of cell wall. Because of the hydrogen bonding between the cell wall, it can provide the transpiration pool effect for the plant. So that is why the water can flow from roots until leaf using transpiration pool against the gravitation force. You know that our Earth got gravitation force, right? If you learn about physics, uh, uh, physics. So, but for plant, it's very special. The water can flow against gravitational force. Why? Because of this theory. Because of this, so water can be pulled. The plant can pull the water from roots to the leaves. Okay. So this theory actually you will learn detail in semester 2. So for those who have retake semester 3 senior, you already know lah what is about cohesion adhesion theory. And if you have retake, you should know about it. Okay. Next is this one also the spatial characteristic for water compared to other molecule, because the water has the maximum density at 4 degrees Celsius compared to other molecule. Because other type of component like alcohol or whatever like salt, they have maximum density when at 0 degrees Celsius. Why 0? Because normally at 0 degrees Celsius, the solid will be formed. Right, solid will be formed normally. But or below 0 degrees Celsius normally, maximum density. But for water, it is very special. It occur at 4 degrees Celsius. Why? Because of hydrogen bond again. All of this property, why it's occur? Because of hydrogen bond. Okay, so actually if you see that, I already say in liquid water, actually hydrogen bond is not very strong. And the water molecule can be flow from any place in liquid, right? Because of hydrogen bonding is not bound tightly compared to solid. When it is bound, it will not bound very bad lah. So it is very easily to break down, compared to solid form. So hydrogen bonding is constantly break and reform. But when you compare to solid, it will form crystalline structure. Why crystalline structure? When you see that the hydrogen bonding will form between the water molecule in very packed structure, because in solid it is very packed structure, right? But if you see that the water molecule packed structure is not like the other types of solid, because if you see the chemistry, the solid normally is very packed to each other. There is no surface. Dia tak ada ruang macam ni punya. If you see water, they are solid, still got have this empty space, right? But compared to other type of solid molecule, solid particle already not have empty space like this. But in water have, because water forms solid due to hydrogen bond. It is not packed to each other one. Dia pack bukan dia pack sendiri punya. Bukan dia pack water dengan water pack sendiri, bukan. Dia pack because of hydrogen bonding. So because of it only pack due to the hydrogen bonding, so water molecule will form the crystalline structure. So that is why the hydrogen bonding are stable at 4 degrees Celsius only. When it below 4 degrees Celsius, actually hydrogen bond is not stable lah. It will not stable. Not stable already. Okay. So that is why the ice can be float on water. Compared to other solid particle, it's very different, right? Because compared to other solid particle normally it will be sink. It will be sink with at the bottom one. But for ice, ice is the solid particle for water. So ice, it will float on the water. Why? Because of this hydrogen bonding. So if you compare to this warm water and warm water normally the hydrogen bonding is very loosely packed compared to cold water, because I already say the maximum density at 4 degrees Celsius, right? Normally cold water is already near to the 4 degrees Celsius. So you will see this structure, you will see that water molecule is more packed to each other lah compared to warm water. But for the ice, because of it is the crystalline structure and got empty space at here between them, hexagonal empty space, right? So because of this, the ice can be float on the water. So this is the very special characteristic for the water. Okay, so that's all for all the properties of the water. So if you see, water have 6 properties in the water: universal solvent, low viscosity, high specific heat capacity, high latent heat of vaporization, high surface tension, and maximum density at 4 degrees Celsius. So actually, these all 6 properties you have to know, and you should know lah. Although in examination so far not come out yet, but in syllabus you have to know. Okay, so that's all for water. So actually 30 minutes already. Okay, I think no question about water, so we are wasting our time, so I will directly proceed to carbohydrate. Okay, if you have any question, you just type on the chat box. I will always alert for it. Okay. Okay. Okay, chapter 1, another topic, biological carbohydrate. So carbohydrate, I think, is the most for chapter 1 most begin the important you guys imagine important topic Water normally you guys not think important, but I already say if you want to score biology, you should understand all of the theory of the stated in NPM syllabus. Okay, carbohydrate. So I think this one, all of you know what is carbohydrate. So one of the example of the carbohydrate you know, like bread, roti, nasi, itu semua kan, nasi, bread, grain, itu semua pokok carbohydrate, right? So in chemistry property, you will see the chemistry structure of the carbohydrate. So the main component of carbohydrate is carbon, hydrogen, and oxygen, CHO. And the formula, if you see here, is the general formula of carbohydrate is CxH2OY. So this is the general formula. So formula, and ratio is about 1 to 1. 1 to 1 is one carbon and 1 oxygen to 2 hydrogen. So when got one carbon, hydrogen must be 2, and also oxygen only have 1. And there are normally have 2 functional groups, hydroxyl group and carbonyl group. Okay. Okay, so actually this is just the general function of carbohydrate. So what are the general function of carbohydrate? Provide energy, right? Yeah. Give us energy. Karena kami kena makan nasi, right? Setiap hari kena makan nasi. Tak ada makan nasi, tak ada energy, tak ada muat untuk bekerja, right? Especially for those who work strongly, like, okay. Okay, so there are four functions. This one I think you can read by yourself. Actually, it's just the general function. So it will produce energy. In oxidizing glucose in mitochondria. It also will oxidize through glycolysis, Krebs cycle, and electron transport chain. So this one you will learn more detail in chapter 5. And also one oxidized polyglucose can synthesis 38 ATP. This also you will learn in chapter 5 also. And also it will carry out metabolic activities, breathing, maintaining body temperature, contraction, and relationship of muscle. So the main function is to provide energy to us. Provide energy. So not only for human, like other type of organism, plant also need energy, right? So all of the living organisms need energy. They need carbohydrate. Okay, so normally in the general terms for short-term energy storage is glucose. So glucose is the general basic, very basic unit for basic example, most common example in nowadays, because all of the organism require glucose. So for this is just for short-term energy storage. For long-term energy storage, for the plant, normally it will store in starch, store in form of starch in chloroplast. And store for animal, it will store in form of glycogen. So starch and glycogen actually is one of the example for polysaccharide. Glucose is basic unit for monosaccharide. Later I will explain it. And also this is just the function. And another function of carbohydrate, it also can be the animal and plant structure. So for plant, actually, if you see plant, glucose, beta glucose actually is the component of plant cell wall. So actually, if you see beta, so anyone, I think everyone how to differentiate alpha and beta, right? So alpha glucose is the general glucose we see lah. Alpha glucose is where the first carbon, the hydroxyl is at the bottom one. For beta glucose, terbalik lah. Dia terbalik. Hydroxyl group at the upper. Ini difference between alpha and beta. And another component is chitin. So this cellulose and chitin actually is the component of cell wall lah. Component of cell wall. Cellulose is component of cell wall. Chitin is the shell component of arthropoda. So what is the meaning of arthropoda? I think Sem 3 senior, you are familiar. But Sem 1, maybe you don't know. Arthropoda is one type of the biological taxonomy organism under kingdom animal layer one. So arthropoda, I give example lah. Arthropoda like scorpion lah. Scorpion, crabs, ketam, dan juga lobster, oyster, prawn, ini semua lah under arthropoda one. So if you know, I use crab lah. Crab, ketam ada itu got shell, right? Crab got shell, right? So prawn also got shell. So the shell component is chitin for this organism lah. Okay, so there are three main class of carbohydrate. This one you all guys already know: monosaccharide, disaccharide, and polysaccharide. So monosaccharide is the basic unit of carbohydrate. So firstly, I will go to the monosaccharide. Is the simplest unit of carbohydrate. So normally you have to know the properties of monosaccharide lah. So if you eat sugar, glucose, eat sugar, you will taste sweet, right? And it is soluble in water, and it is colorless. If you make a sugar water, it is colorless, right? And it can be crystalline, and sugar is solid, right? Crystalline. And also it acts as a reducing sugar, meaning that it is act as reducing sugar. It can be oxidized by tolerance and Benedict reagent. So this one, I think Sem 3 you are a bit familiar with it. Because Sem 3 you will learn about what is tolerance and Benedict reagent. But in biology now, you only learn Benedict reagent, right? meaning that Benedict reagent is you can form big red precipitate, right? Copper 1 ion will be precipitate become copper 2 ion. Copper 2 ion become copper 1 ion. If you are not mistaken. This one actually you already learn in SPM lah. Okay. Okay, for the empirical formula for the carbohydrate, so the monosaccharide is based on the classification is based on the number of carbon lah. Either it has number of carbon of 3 until 7. So normally in nowadays, the monosaccharide, the basic unit, the least number is number of 3 for carbon, and the highest one is 7. But normally for us, normally we use 5 or 6. In general metabolism, in biochemistry, normally 5 and C equal to 5 and 6 are the most common one. 3, 4, and 7, either you go to the biological research, you will see it, but normally you will not see it very well. But you have to know lah. Okay, so the name is based on the the name is like that. So number 3 with triose, meaning that it has the carbon is C equal to 3. Tetrose, pentose, hexose, and heptose. So these are the common example. So this one is also common example. You can refer to it. So hexose is the most common lah. Okay, so another one is a classification according functional group. So the first one is according to the number of carbon, and another classification is according to the functional group. So they are normally monosaccharide contain 2 main functional group. Either it is aldehyde group or ketone group. So these are belong under carbonyl group. Carbonyl group. So carbonyl group is C double bond O. This one, if you for senior, you already know, but for sem 1 junior, you don't know, never mind. Explain. So C double bond O. The carbonyl group is the group that is C double bond O. Okay. For aldehyde which is called aldose sugar. The carbonyl group is at the end of the carbon skeleton. So if you see that the carbonyl group C double bond O is at the end one, either here or either here. But for ketone group, the C double bond O is within dekat tengah-tengah punya, at the inner side. Either if this for the C3 lah, for C4 it either can be located at the C2 or C3. If like C6, it can be either located in C2, C3, C4, C5 like that. So either it is under aldehyde group or either ketone group. So if it is ketone, it is ketone sugar, like glucose molecule. Glucose is fructose. Sorry, fructose. Fructose is under ketone sugar, and for glucose is under aldose sugar. So if you classify glucose, the general name is aldose hexose sugar. So aldose sugar, the normally is either glucose or galactose. Okay, so this one same, but more detail. So if you compare to the hexose sugar, so glucose and galactose is under aldose because the carbonyl group is at the end. So what are the differences between glucose and galactose? So it is differences between 1, 2, 3, 4, carbon number 4. So if you see that carbon number 4, for the glucose, the hydroxyl group is at the right hand side, but for the galactose, the hydroxyl group is at the left hand side. So this one you should remember lah, what are the difference between glucose and galactose. But and for the fructose, it has also for hexose sugar 6 group, 6 carbon, but the carbonyl group is at the carbon number 2. Dia dekat tengah punya, at the middle side one. It's not at the end one. So that is why we call it is ketone sugar, ketone group, and the general name is called fructose. And just naming so either is the aldotrio, ketotriol, that this is just a general name only. But if you want to common name is this fructose, glucose, galactose, ribose, ribulose, pentose, like that. Okay. Okay, and this one I think is more important to you guys. So arrangement of the monosaccharide. So if you see this structure, actually this is the linear ring form. If you write in organic chemistry is in the linear ring form one. So actually, if you see in your textbook, your glucose molecule is right in ring form right. So arrangement of monosaccharide, if the carbon is more than 5, it can be exist in straight chain form or in ring structure. But normally we use ring structure lah. So it change from straight chain to ring structure when dissolved in water. So normally when the monosaccharide like glucose, when dissolved in water, it will form ring structure. And then only the ring structure can be used to make disaccharide and polysaccharide. So if you want to form disaccharide and polysaccharide, it need to dissolve in water. So when the monosaccharide like glucose, fructose, pentose like that, it not dissolve in water, it will cannot form ring structure, and no ring structure, it will cannot form disaccharide and polysaccharide. So this is the linear ring form, and this is the ring form lah. The ring form that you will see in the textbook. So how it can form ring form? So if you see this, okay. So this one is ring form. This I use the glucose molecule as alpha glucose molecule as an example. So you see this. So normally in ring form, we will count the number of carbon from here. 1, 2, 3, 4, 5, 6. This one we count carbon from carbonyl group. So if you see that in ring form, actually carbonyl, you will see that there is no carbonyl group. You will think that carbonyl group already hilang. Because carbonyl group is C double bond O, but this one is only C single bond O only. So actually, they form the ring like this first. So C dia akan tukar dari sini lah. C dia akan bonded with C number 2, right? C number 2, C number 3, C number 4, C number 5. And then C number 5 also bonded with C number 6. Okay. Now how to bond from C number 1 to C number 5? Macam mana? So C number 1 got carbonyl group and hydrogen atom. So C number 1 it will be modified. Dia akan modify the real mechanism. Actually you don't need to know. Dia akan modify with the hydroxyl group from C number 5, and then the C number 5, the oxygen atom will directly bond to the C number 1. Okay, so how about this hydrogen atom? This hydrogen atom will come to the C number 1 punya O. Dia akan pergi ke sini. So finally you will form here. So that is the structural change for C number 1 and also C number 5. All of this, not only glucose, all of the hexose sugar, glucose, galactose, and also fructose, semua macam sama aja. C number 1 and also C number 5. Okay, so if you see here, C number 1, dia akan bond directly to the C number 5 punya O, and then C number 5 punya H, dia akan pergi ke sini. The real mechanism you don't need to know. You don't need to know it because it's very complex. But if you want to know, you can Google about it. Okay, so finally you will form this structure. Okay, C number 1 and C number 5. You just want to ingat C number 1 and C number 5 is the key to change the structure become ring form. Okay, so now just now is about glucose. How about fructose? Actually, if you refer to the ring structure of fructose, actually it is not hexagonal shape one. For fructose, it looks like pentose. pentagon. Dia macam pentagon. So actually you see this. So if you see the fructose one, the ring form, dia macam pentagon one. Dia macam pentagon. Dia bukan hexagon like glucose one. Why? Because of carbonyl group. Because the carbonyl group for fructose is at C number 2. Because C number 2 carbonyl group need to be modified. Compared to glucose, the carbonyl group is at C number 1. So it can directly modify, it can directly modify, but C number 2. So for glucose is C number 1 and C number 5 need to be modified, but for fructose it is C number 2 and also C number 5 to be modified. So if you see this structure, so C number 1, it ring to C bonded to C number 2, number 3, number 4, number 5, number 6. Same as glucose, at the beginning. Dia macam sama dengan glucose 1. But for the C number 2 and C number 5, it need to be modified. So I already say macam mana? For glucose, dia macam mana? For glucose C number 1, it will directly bond to the oxygen atom for C number 5, right? Same as here, C number 2, it will directly bond to the oxygen for C number 5. So dia akan berjadi macam ni. And then the hydrogen atom will come to the hydrogen atom for C number 5 will come to the C number 2. So it will form hydroxyl group. So that is why because of carbonyl group for fructose is at the C number 2. So when it form the ring bonded with the oxygen from C number 5, it will form like the pentagon structure. Because of C number 1 dia letak dekat sini. C number 1. This is not C number 1. This is C number 2. If you count the number of carbon, C number 1 is starting at here. But for glucose, it starts at here, right? But for fructose, it starts at here. 1, 2, 3, 4, 5, 6. So this is the in exam. If the exam normally is structure question, asks you to draw the ring structure of fructose. This is the answer lah. You have to draw it. Memang kena draw lah. So ini memang I don't know the examination got give this structure being linear structure or not. If no, you have to memorize it. Okay. Okay, next one is function of monosaccharide. I think this one you can read by yourself. I don't need to explain much because it's just a general function. Okay. Okay, next I will proceed to disaccharide. Okay, disaccharide carbohydrate that join by two monomers through condensation by glycosidic bond. So monosaccharide is just the basic unit. Only one unit only. Disaccharide is combination of two units through condensation reaction by glycosidic bond. So normally the property of disaccharide is same as monosaccharide except sucrose act as the non-reducing sugar. So why sucrose is non-reducing sugar? Because sucrose does not have free ketone and aldehyde group. So if you know at the theory, we want to become reducing sugar, meaning that the sugar need to be reduced. But how to reduce? Sugar need to have the free ketone group or aldehyde group to be reduced. If no, the sugar cannot be reduced to alcohol. Okay, and this group so why does not have free aldehyde ketone and aldehyde group? Because all of this group already involved in the formation of glycosidic bond already compared to other types of disaccharide. Okay. Okay, so this is the general formation of disaccharide. So the formation of disaccharide is through the condensation of two monomer. So the joining together through the glycosidic bond. So it will form one glycosidic bond here between two monomer. And if we mention condensation, one molecule, water molecule will be released out. So the example is glucose formation of maltose. Glucose will form maltose, right? So if you see this, the carbon number 1 and also carbon number 1, 2, 3, 4. Carbon number 4 will condense and then it will form the glycosidic bond. So if you see here, carbon number 1 and carbon number 4. So that is why we call 1,4 glycosidic bond, because it involves the bonding is involve carbon number 1 and carbon number 4. Hydroxyl group lah. Dia akan involve hydroxyl group 1. Okay. Okay, next is about these are the example. Maltose lah. Maltose I already explained. For lactose also same. So lactose, the monomer is galactose and glucose. So if you see here, glucose and galactose will form lactose, right? So same 1, 2, 3, 4. One it also will form 1,4 glycosidic. For sucrose, it is combination of glucose and fructose, and this one will form 1, 2 glycosidic bond. Dia akan for glucose carbon number 1 and also fructose for carbon number 2. Carbon number 1 and carbon number 2 will form glycosidic bond. This one is same, dia sama dengan itu maltose lah, carbon 1 and 4. Okay. Next one is about oligosaccharide. Actually, this one I involved in because of some of the books or some of the question come up this term, but normally nobody knows because they think that this term is very new. Actually, oligosaccharide is, you can say it is the subgroup of polysaccharide lah, but it is more shorter compared to polysaccharide because it normally involve 2 to 10 only lah, 3 to 10 lah normally, 3 to 10 monosaccharide only. So this one I just pass through only. So property of oligosaccharide, soluble in water, test sweet, and classified based on the number of monosaccharide. So this is the classification: disaccharide, trisaccharide, tetrasaccharide, pentasaccharide. So you can see it. So biphenols, sterols, babascos. So these are the type of monosaccharide lah. So this is the structure of biphenols, sterols, babascos, and okay, that's all. Okay. So this is just example I go pass through only. Actually, it's not important for Stpm 1. So polysaccharide. It is very important, I think. It is very complex and very large in size of carbohydrate. So compared to oligosaccharide normally is 3 to 10 monosaccharide. For polysaccharide, it can be 100, even 1,000 number of monosaccharide. So properties of polysaccharide, it is very insoluble in water, does not taste sweet, and is totally non-reducing sugar. So it is totally different from the monosaccharide and disaccharide one, because one of the example is rice lah. Where is rice soluble in water? Is rice taste sweet? No, these two confirm no. Kalau awak makan nasi, awak tuang nasi ke dalam air, is it soluble or not? No, right? Kalau awak makan nasi, awak rasa manis ah? Bukan. Manis. Manis tak? Takkan. Itulah semua. Semua. So, okay. So actually, type of polysaccharide. So actually, there are two main types of polysaccharide: homopolysaccharide or heteropolysaccharide. So normally in our syllabus, we only cover homopolysaccharide because we only contain one type of monomer only. So main monomer is glucose molecule lah. So our main monomer is glucose molecules like starch, glycogen, and cellulose. All of these are made up of glucose molecule one. For heteropolysaccharide, it is more advanced one. So normally it contains two or more types of monomer lah. So it is not only made from one type of monomer like glucose. It is not only made from monomer, but also have more than one type of monomer like glucose, galactose, fructose. All of these campur together and then form one type of polysaccharide. One of the example is hyaluronic acid lah. Okay, ini just bagi gambar je. Okay, so the function of polysaccharide normally energy storage act as the energy storage lah. So for I already mentioned Before that, animal is for glycogen, for plant is for starch. Okay, so it made the cells more hydrophobic due to the formation of hydrogen bond between monomers. This lower the sugar concentration, cause the cell can intake more sugar. So this one is increased to ensure that the cells can intake more sugar. If we store in terms of polysaccharide, if human or plant only can store monosaccharide, cannot store polysaccharide, meaning that the sugar that we take cannot too much. Maksudnya lagi cepat gemuk lah. Kan? Lagi cepat gemuk lah compare to no polysaccharide. Maksudnya like one you cannot eat polysaccharide. You only can like one day you only can drink Coca-Cola like that. You only can drink sweet water, 1 cup of sweet water, then enough already. Enough already. So actually it is not suitable. So that is why that our cells will store the sugar in terms of polysaccharide. And also cellular communication. So if you see that we have got glycoprotein and glycolipid, right? This term you will see at chapter 3, plasma membrane. Plasma membrane, we got glycoprotein and glycolipid. So these are the carbohydrate that bound to the protein, and for the lipid is bound to the lipid. So that's why we call the glycoprotein and glycolipid lah. So it is act as the cellular communication because it is normally bound to the plasma membrane. You will find it on the plasma membrane. And also for cellular support, I already mentioned cell wall component for plant and for fungi chitin. Okay, so example of polysaccharide. So normally, if you see that the example polysaccharide, normally 3 types, right? Starch, in our syllabus, starch, glycogen, and also cellulose. But before that, we have to know the structure of the polysaccharide first. So in general, our structure of polysaccharide is got 2, amylose or amylopectin. So these two structure actually will form the example that we know, starch and also glycogen. So for amylose, actually it is an unbranched polysaccharide. This is the keyword, unbranched. So consists of alpha glucose that link together by alpha 1,4-glycosidic bond because it is condensation of the glucose, right? So normally it is very normal condensation, just it is very long only. Very long lah. Very long, but it is unbranched. Maksudnya dia akan satu line saja. Dia hanya satu line only. One line only. And then amylose can dissolve in hot water to form a soluble starch where the hydrogen bond will be break by the heat from the hot water. Okay. So this is the amylose. Okay, another one is amylopectin. Okay, amylopectin is a branched polysaccharide linked by 1,4-glycosidic bond but occasional with alpha 1,6-glycosidic bond, meaning that amylopectin is the branched one. It is not only got one straight line, but also it will branch with 1,6-glycosidic bond in another line. If you see here, it got 2 lines, right? One line and another line. So if you ignore the upper part, the bottom part is just known as amylose. But for amylopectin, it will be branch. Dia akan ada satu jabatan lah. Ada satu bridge. I can say that is one type of bridge. Akan satu bridge they connect to each other lah. Another line, you can see lah. You can say that there are another line of amylose that connect with another line of amylose. So they connected with each other for this for this bond, for got 1,6-glycosidic bond. So this give a more open molecular structure than amylose and prevent helix formation. And amylopectin is more easily hydrolyzed compared to amylose because 1,6-glycosidic bond is not very strong compared to 1,4 because and normally 1,6 glycosidic bond the number is very little because it just only want to connect to another line of aminos only. Okay, so in this structure, you can see that amylose normally it looks like this. One line only. You see that it can form helix structure. Satu line saja. Satu line saja. But if you see amylopectin, dia macam open punya. Dia macam sangat awak tengok macam sangat sangat complex lah. It look like very complex because it have branch. So if you see that the one line here and then suddenly at here it bound to another line of amylose. So there are two. You can say there are two amylose at here, because of this. They connect together. They connect by the 1,6 glycosidic bond. Okay, so one of the example is starch. So starch is made from alpha glucose. So if you see here, see these two structure. So starch normally is helix structure lah. You see here helix structure. So dia akan hanya satu line saja. Satu line saja. Normally. But got some starch. Some starch also have branch amylopectin, but the branch of the starch is very little compared to glycogen. You see glycogen is highly branched punya. Dia awak tengok dia, you see that got just the very near already have branch. Very near already have branch. If you see this structure, sorry. If you see this structure, very near one aminopectin, I assume that this is one aminopectin. You will see that this already have one branch. Already one amylose got 5 to 6 branch already. So compared to the starch, the branch is not very high in amount, little only. So normally starch is the energy storage for plant. So exists in two form, amylose and amylopectin, but generally is amylose. Okay. But for glycogen, normally it's very highly branched because it contains alpha 1,4 glycosidic bond and it is the animal starch. Because our animal human, we store the energy in terms of glycogen, not starch. And then glycogen is less dense and more soluble than starch, so it is a more suitable storage polysaccharide for animals. And glycogen clump together to form small granules and are most often stored in the liver and muscle cells. So normally, liver and muscle cells will store granules. Not all of the cells in animals will store the granules, but normally liver and muscle cell will take part about it. And this is just the extra information. If we want to hydrolyze the glycogen, we will require glycogen phosphorylase, the specific enzyme to hydrolyze it. And for starch, normally we use amylase. We use amylase, already can hydrolyze the starch. But for glycogen, we can use the specific enzyme called glycogen phosphorylase to hydrolyze the glycogen into the glucose molecule. Okay, another one is about cellulose. So cellulose totally different from the starch and glycogen because it does not have amylose and amylopectin structure, because our cellulose is made from beta glucose. So if you see here, it also form 1,4 glycosidic bond. But I already mentioned that for if you still remember the differences between alpha glucose and beta glucose, the hydroxyl group is at the bottom. But for alpha glucose, the hydroxyl group is at the upper part one. If you remember, you will still remember. You need to differentiate between alpha glucose and beta glucose very clear. This is just the basic knowledge. So beta glucose, the hydroxyl group is at the bottom. Also it can form the glycosidic bond, also form 1,4 glycosidic bond, But if you see the structure, actually it is oriented 180 degrees Celsius to each other. So if you see here, it is carbon number 1, but carbon number 4, carbon number 4, carbon number 4, carbon number 4 is at here. But if you see the structure, it is very totally terbalik. Kami cakap senang terbalik. So macam mana? So carbon number 1 is at here. 1, 2, 3, 4, 5, 6. You will see here 1, 2, 3, 4, 5, 6. It is very clear if you see this CH2OH and CH2OH here. Dia memang terbalik, totally terbalik. This is if you for the alpha glucose not terbalik one, semua sama aja. 1, 2, 3, 4. For alpha glucose 1, 2, 3, 4, 1, 2, 3, 4 semua sama aja. But for cellulose beta glucose is totally different. You see that 1, 2, 3, 4 for this subunit, for this unit, and you see here this is not already, this is also 1 but not count from here. Count terbalik. 1, 2, 3, 4. This one count count to the bottom. This one count to the upper. So dia semua terbalik. So 1, 2, 3, 4. This one also dia terbalik lagi. 1, 2, 3, 4. Ini terbalik lagi. 1, 2, 3, 4. So memanglah dia totally different one. So this you have to learn, and in examination, if you want to explain the characteristic of the cellulose, you should write this. Oriented 180 degrees Celsius. This you must write it. This is the key point, the key point of the cellulose, and also beta glucose. You need to write beta 1,4-glycosidic bond, not just 1,4-glycosidic bond. If you just write 1,4-glycosidic bond, sorry, no marks given. Only you have to add on beta. Okay. And then this one also, the cellulose chain run parallel to one each another. So this means that totally parallel line. It is not unbranched, and not even unbranched also for starch. Even it is unbranched, but it can form highly structured, right? It is not parallel. But for the cellulose, it's totally parallel. Totally parallel and got hydrogen bond. So if you see that, actually the hydrogen bond can form from between the line. Hydrogen bond can form between the parallel cellulose molecule to hold them together. So can form hydrogen bond, and then the chains will group together to form microfiber, which are arranged in larger bundle to form microfiber. So this fiber will give the structure of the plant cell wall. So actually cellulose is the basic component for plant cell wall, right? So the function is the structural polysaccharide in plant cell wall. So when they group together, they will form microfiber and then arrange in the larger bundle to form microfiber. Okay. Okay, and then this is extra information that human actually cannot digest cellulose. That is why when we eat plant, eat vegetable, actually we cannot obtain full nutrient from the plant one, because plant got cell wall. Unless you break down the cell wall of the plant, if not, actually we cannot get full nutrient from the plant one, because our human does not contain cellulase enzyme to break the 1,4-glycosidic bond in cellulose. We don't have the cellulase enzyme, right? Only the cow, like the cow, sheep, this one herbivore animals have cellulase. Cellulase to hydrolyze cellulose. But for animal, we don't have sorry. So the only organism that possess a cellulose enzyme are bacteria. Bacteria, not only bacteria but also herbivorous animals such as cow, termites. Termites also can hydrolyze the cellulose because they have cellulose enzyme. Okay. This is just structure of cellulose. So okay. This one actually just extra another component not stated in NTA syllabus, but just extra information for you. Chitin, you don't need to memorize it. So one of the polysaccharide lah, chitin. So the main component of fungi cell wall and also shell of arthropod. So this is just the ini just the basic knowledge lah. Just this one, if you further study, maybe you further study biology in degree, you will learn about it. If not, Stpm, you don't need to learn. So the most important things for polysaccharide is starch, glycogen, and cellulose. This is the most important one. Okay, so that's all for today class actually. So I hope that everyone can get the information, can get the knowledge from here. Because although these two topics are very easy, I can say it's very easy and very boring. I know, I know it. But anyway, you have to master it, understand it very well. Not only just screening, but you have to understand it very well. Okay, as I mentioned, the class discuss no record. I will not share this. I will close this link. You cannot further access this link again. So if you want to buy the recording or buy the notes for here, you need to pay lah. Pay for notes is 5 ringgit. 5 ringgit. Per topic. For video is 10 ringgit lah. So for video is just for today lah. For today one, 10 ringgit each video. So you can, if you interesting, you can scan this code, and also I will post it into the Telegram channel. If you interesting, you can buy it. So that's all for today, and thank you so much for listening my class. So that's all for today lah. So see you guys tomorrow. So tomorrow I will proceed to protein and lipid. So another two biological molecule. So that's all for me. So have a nice day. So for India, happy Diwali for you guys, and have a happy holiday lah. I think not happy holiday yet, but good luck for you lah, and also for your examination for your future. Thank you. I will open this until 9:20. 9:20 I will close the link. Okay. If you have any question, you just type on the chat box. I think so far no question at here, so I think it is too easy. Maybe too easy already. Okay.